So let's just walk you through the process here of what this would look like. So we've got some data for the average temperature on April 14th for the last 21 years in two different locations, Des Moines, Iowa, and San Francisco, California. This data is listed here so you can sort of see it. I've also given you a dot plot below so you can sort of visually see the two plots right next to each other. The data is also saved here in this April14Temps.csv data set. So in order to work with that data set, you're going to want to download it to your computer. So click this button. It may prompt you to, on my computer, it asks me where I want to save it. So you could save it in your downloads folder, or I have a specific folder on my computer for all my Stat 52 stuff. So you can see it already saved in there and you could save over it. Okay. It may just prompt you to sort of save it on your downloads, and that's fine too. Remember, if you click on it here, your computer may or may not know what sort of program to open it in. So if it opens in an Excel, it'll sort of format it nicely. Let me pull it up here in Excel. See, here's the data in Excel. It'll be formatted pretty nicely in terms of being in different columns. If it tries to open it in your web browser or in a Word file or something, it's going to look like a big ugly mess of some numbers separated by columns or by commas, sorry. But we need to take this data and import it into StatKey. They've said to use StatKey and the data to find the mean and the median. So those would be measures of the center of the data. And so I've gotten the solutions here, but let's just walk through how to do that. So I'm going to click one quantitative variable in StatKey. Let me just do presentation mode so that the number is a little bit bigger here. You're going to select that you want to upload a file. Then you're going to navigate to your computer wherever you saved this April 14th temps thing. It may be in your downloads. It may be in your Stat 52 folder. If you're not sure, you should be able to search to figure out where you saved it. Okay. So there's April 14th, and I'm going to start with Des Moines just to start. So we'll do Des Moines. I'll select that as my column and press OK. Then you can see that this dot plot is here. It's the same as this dot plot here. And all my summary statistics are here on the right. And by now, you actually should know what all of these values are. The video on standard deviation and spread talked about the minimum, Q1, the median, Q3, and the maximum. So you should know how all of those are defined. Essentially, they're taking your sort of data points. There's 21 in this case. The median is exactly in the middle where half the points are below and half the points are above. And then Q1 and Q3 divide that. So wherever the middle of the data is, in this case, 54.7, we're going to count into the middle where there's 25% below and 75% above. That's my Q1 value. And my Q3 would be where there's 75% below or 3/4 below and 1/4 above. Okay, and we can use those to calculate the interquartile range. Got a little sidetracked there. Essentially, StatKey has asked us to find the mean and the median, which are both measures of where the middle of the data is. So you can see the mean is 53.952, which is why I have that here. And the median was 54.70. Okay, so those are measures of the middle of where the data is. So again, here's the temperatures in Des Moines on April 14th, and you can see that the middle is around 53 or 54, depending on what measure we use. To do it for San Francisco, you'll have to upload the data again. There's no way to sort of, oh, I guess here you could click change column. Okay. And you're going to select the San Francisco column instead. And again, here's all your summary statistics if you need them. In particular, in this case, we're interested in the mean and then the median, which are both listed here. And in this particular case, you can sort of notice that the means and the medians are actually quite similar between Des Moines and San Francisco. Both of them seem to have the measures of the center right around 53 or 54, right? And so in terms of thinking about these two places on average, their centers are very similar. When we get to part B, they've asked us to look at the standard deviation, which is a measure of the variability of the data. Okay, and just from looking at this dot plot alone, you should be able to see that in San Francisco, the temperatures are much more consistent. They tend to be closer or clustered around this more, whereas the points tend to be spread farther apart in Des Moines. There's a lot more variability in the weather in Des Moines. I've never lived in Des Moines, but I lived in Davis, California, which is close to San Francisco. And I remember it was very funny having grown up in Canada, where I was always checking the weather. When I moved to San Francisco, or when I moved to Davis, which is near San Francisco, I almost didn't even need to check the weather because I sort of knew the temperature was all going to be about the same as yesterday. Whereas in the Midwest or here in Vermont, the temperature tends to have much more variability to it, right? Okay, so in terms of actually quantifying that variability, we can use stat key. And so that's this standard deviation. And I'm only ever going to ask you to calculate the standard deviation using stat key. So the standard deviation is there for San Francisco. It's 3.15. Okay. And again, I'll choose a different column for Des Moines. And that's how I'm getting that the standard deviation for Des Moines is 11.052. Standard deviation is hard to interpret. And the video should have walked you through a little bit about what it means. But I think in terms of this class, the important thing is that you can compare these two numbers, right? So it's a smaller number, or there's smaller variability in San Francisco, right? There's not as much spread there. The numbers, the temperatures are very close together in San Francisco. They tend to be more consistent. Whereas in Des Moines, this number is much larger, meaning there's a lot more spread or more variability in Des Moines in the weather, right? You might want to check your weather app more often if you're in Des Moines to sort of see what the temperature will be compared to in San Francisco. Maybe you can know more consistently that it's going to be, closer to this measure of the middle.